Properties of matter. Here's the objectives here. First is identify properties of matter as whether they are extensive or intensive. Second, you want to be able to define physical property and list several common physical properties. Third, differentiate among the different states of matter. And last, describe a physical change. So those are the kind of things that you need to be able to do in section 2.1. All right, so properties. If we're talking about properties, we can classify them as either extensive or intensive. And if we're talking about extensive properties, these are ones that depend on the amount of matter. So for instance, we're talking about mass. So if I have this pile of sand, the mass would depend on how big that pile of sand is, or the volume. Those are extensive properties. Intensive properties, on the other hand, don't depend on the amount, it just depends on what it is. So if we're talking about density, or if we're talking about its composition, those would be examples of intensive properties. Make sure you understand what a substance is. A substance is something that has uniform and definite composition. Uniform meaning it is the same throughout. So uniform, definite, kind of similar terms there. Every sample of this substance must have identical intensive properties if it has the same composition. That's what we're talking about in a substance. It's going to have the same properties throughout the whole thing. And if we want to talk about physical properties, we're talking about some type of property, quality or condition, or something that you can measure without changing the substance's composition. So for instance, you could measure the boiling point of water. While it might be changing state, it's not changing its composition. It's still H2O. So you can measure that, boiling point, freezing point. Those are examples. Density, those are examples of physical properties. And of course, you're probably familiar with the states of matter. If we're solid, make sure you understand that solids are going to have definite shape and definite volume. You'll be able to measure it. It's going to sit, if you set it on your desk, it's going to stay in the same shape. It's going to have that same shape and volume all the time. Liquid, on the other hand, it's going to take the shape of its container. It's free to flow. So, if we took a glass of water, it's going to fill that container. It's going to take the shape of the container, but it doesn't have any definite shape itself. And gas has no definite shape, no definite volume. It's going to take the shape and the volume of the container. You put it in a small balloon, it's going to fill the balloon. You open the balloon up, it's going to spread out into the room you're in and take up all that space, however much that you have. Physical change, if we want to have a physical change, is a change where we change the properties but not the composition. So we might do something like boil something, freeze something, melt, condense, break, split, grind, cut, crush. Notice they're all, a lot of these are action verbs. So when we do those things, those tend to be physical changes. And they can be considered reversible or irreversible. So for instance, I can boil something and then I can melt it. That's reversible. On the other hand, if I take a piece of paper and I cut it, I can't uncut it later. So there are some things that can be reversible, some things that can't be reversible. All right, section 2 is on mixtures. And here's the objectives for section 2. Categorize a sample of matter as a substance or a mixture. So make sure that you can tell the difference between the two by looking at something, being able to tell. Distinguish between homogeneous and heterogeneous. And describe ways that you can separate mixtures. Those are the key things. So when we're talking about a mixture, what we mean is simply a physical blend. We've taken two things, put it together, blended it, didn't create new components or new compounds or anything. It's just a blended substances put together. And those mixtures can be two different things. We could have them heterogeneous, where they're not the same. If you see the picture of the sand or whatever that is, you can see it's different throughout. It's not the same. On the other hand, you could also have ones that are homogeneous, and homogeneous means they are the same. And we consider those to be solutions. So, you have homogenized milk, where, there's the cream and the milk, and they've treated it so that it doesn't separate out. If they didn't homogenize it, if you let it sit even in the fridge for a while, it would separate into cream on the top and the milk on the bottom. And if something like that, if you do have those different parts, those would be known as a phase. And sometimes you can have different substances together where you have different phases that are uniform, and then they change from one to the other. We're going to use these physical properties in order to separate the mixtures. And there's probably two main ways that are pretty simple to do. Filtration is one, where you simply are going to take and run it through some kind of filter that's going to separate the solid from the liquid. So if you had sand and water together, you could put it in there and it'll separate the sand from the water. Or distillation is another way of doing that, where you could take something that you're going to boil it off and separate. So for instance, like if you want to separate salt and water, you can't run it through a filter and separate it, but you could boil the water off and recondense that water and get the separate water by itself, and then have the salt left back in the original container. All right, so there you go.